What's up, hackers? Welcome to TTI Live. My name is Taggart. Been a minute, missed y'all. So tonight, we're going to be writing some Rust, and we're going to be writing some Rust code specifically to do a proof of concept for a common ransomware actor technique, which is deleting volume shadow copies, but we're going to do it stealthier than usually you see it to demonstrate that it is possible to do it stealthier than you've seen it, right? So we'll talk a little bit about what that is and how it works when we get started. But of course, OreoBite, thank you very much, first of all, for the 15 months of subscription. Really appreciate that. Has immediately requested a song, and I must comply. I am compelled to. So we're going to get that out of the way right at the top of the show. Get that all sorted. Now, I apologize if you can hear the wind fluttering a bunch of stuff outside. We have 30-mile-an-hour gusts today for reasons surpassing understanding. All right. So I had this one queued up, so we'll do this one.
I want you, thin finger. I wanted you, thin fingernails. And when you burn backwards, I wanted to. I needed you to make me better. I love you in springtime. I lost you when summer came, and when you pulled backwards, I wanted to, I needed to make me better. Oh, to make me better. But we're not so starry-eyed anymore, like the perfect paramour you were in your letters. Won't it all just come around to make you, let it all unbreak you to the day you met her? It'll make you better. It'll make you better. It'll make you better. I sung you your twinges, I suffered you your tattletales, and when you broke sideways, I wanted to, I needed to make you better. Oh, to make you better. But we're not so starry-eyed anymore, like the perfect paramour you were in your letters. Won't it all just come around to make you, let it all unbreak you to the day you met her? It'll make you better. It'll make you better. It'll make you better. call mine. All I wanted was a shimmer of your shine to make me bright. But we're not so starry-eyed anymore, like the perfect paramour you were in your letters. Won't it all just come around to make you let it all unbreak you to the day you met her? It'll make you better. It'll make you better. It'll make you better. All I wanted was a sliver to call mine.
All right, back to work. Right, so what are we doing tonight? We are dealing with volume shadow copies, to start, at least. That's the first thing on the agenda. So very commonly, you'll see ransomware actors do something a little bit like this. They will run, let me get the admin PowerShell up. They'll run VSS admin. VSS admin is the admin tool for volume shadow copy service. Now, here's the thing that's kind of interesting. The volume shadow copy service allows you to list providers and list shadows. It doesn't actually allow you to make shadow copies, but it does allow you to delete them. So check this out. If I do VSS admin list shadows, now luckily I'm just doing this on my own machine. I've got plenty of shadow copies here, actually. I've got a couple on my C drive, and I just made one on my external drive. And this by itself will be enough to trigger a lot of EDRs. A lot of automated tools will alert, or managed security service providers will have signatures for this, and you should too if you're responsible for things like that. Because just this listing of shadow copies is weird, right? Sometimes administrators will do it, but it's pretty uncommon. And it's uncommon enough that, yeah, even if you get a false positive, you kind of want to know that it's going on. Hey, 6 Samsa, maybe? Thanks so much for that follow. All right, so the listing is bad enough, but of course, if we did VSS admin delete shadows, right, that is an obvious alert, because now we're deleting. Why are we deleting volume shadow copies? Deleting volume shadow copies are a precursor to detonating ransomware. See, volume shadow copies are a backup service. They're a little bit interesting the way that they work. I won't go into all of the technicals. I'm only barely beginning to understand them myself. But they're not just like an image, right? They're not just like a DD backup of a disk. That's really not what they are. It turns out that applications, including your operating system, have the ability to hook into the volume shadow copy service. And that they can provide information to the volume shadow copy. So the way that it works is a little bit more involved, just like anything in Windows, than you might imagine. It's not as straightforward as you might think. But once the thing is created, you have to use the volume shadow copy service to enumerate the copies that you have and then manage them. So, by the way, you might ask, well, okay, if you can't use the VSS admin tool to make shadows, how do you do it? Great question. The answer is WMI. So you can run WMIC shadow copy call create volume and then give yourself a mounted drive and you're good to go. That will create a shadow copy. So that's cool, but we actually want to do the opposite, right? We want to learn how to blow these away. So because again, the objective is to emulate threat actors, and in this case, slightly more advanced threat actors. Does WMIC require higher privileges? You bet it does. It absolutely requires admin privileges on the local system that you are executing the command on. Yep, it sure does. And in fact, what's going on, the volume shadow service provider in the background has to be running a system. That's not, no, you don't have to be system, but yeah, you definitely have to have an admin token to even get this far. So that's something to be aware of. And of course, when we see successful ransomware attacks, that's exactly what's happening, right? In order for that to work at all, they're going to have elevated their privileges such that, one, they can propagate throughout the network, and two, that they're able to get to the parts of the file system that they want to get to outside of any individual user account that they may have compromised. So we're sort of taking that admin privileges as given. Right? We're not worried about privilege escalation right here. We're kind of thinking a little bit further down the kill chain, if you like. Okay, so with that in mind, let's think about how we do this without executing a PowerShell or a command, without invoking WMIC or VSSadmin. Because invoking VSSadmin.exe directly like that is an immediate detection. Everybody's got that covered. Okay? So if you do that, you're going to get burned if you're an offensive operator. Do it if you're trying to test for it, but that should get you caught, right? But here's something that might not get you caught, which is directly invoking the Windows API to do it. If we dive down into the Windows API deep enough, we will find IVSS backup components delete snapshots. This is the function that makes the snapshots go away. The trick is that it has some prerequisites. Before you get to be able to call this function, you have to have a lot going on. So we're going to kind of walk backwards from delete snapshots. How do we get there? And build out this, what ends up being COM programming in Rust. So that's the plan for tonight. And then if we have more time, we'll play with some other stuff. But that's the plan. So first of all, I'm looking here at the Windows API documentation. That's great, but it doesn't really help me do it in Rust. This does. So this is the Win API crate, which is not, I should mention, it is not the official Windows crate. There is a Windows crate, which I tend to prefer. The problem is that the Windows crate, at least last time I checked, does not expose this function. We can check right now. Right, Rust for Windows. This is the actual Windows crate. Come on, there's the documentation. It takes forever to get to it. Let's just get as far as VSS backup components. Let's see, which we'll talk about in a second, but nothing. VSC backup components, maybe? Wow, nothing at all. Okay, so is it? I feel like it should be in storage. Nope. System. VSC. Can I post these links to Discord later? I mean, I can post them to the chat right now. There's your Win API, and here it is in the actual Rust crate. And what are we working on? So to demonstrate this, I have gone ahead. I couldn't stop myself. I made myself a new Git repo called Corroded Shadow. I don't know. I'm in a mood. So Corroded Shadow is going to be our proof of concept for this. And this is, of course, open source. So anything that we do tonight will be pushed to this repo. Have fun with that. Right. So yeah, nothing in VS Backup. That's really interesting in the Windows crate. And this is kind of what I was talking about, was that... Okay, here we go. So, yeah, it like, this was when I started looking into this, this is what I ran into, that the Windows crate just doesn't expose this stuff, right? So we have to fall back to the Win API crate, which is fine. The reason why I don't like working with the Win API create, as we'll see tonight, is that when you build with it in Linux rather than on Windows, it really gets mad. Because the way that Win API works is that it's they're directly addressing DLLs, and that's just something that Rust Analyzer on Windows, or sorry, on Linux, because it doesn't have access to those DLLs, it's like, well, I don't know what's happening. And it can compile just fine, but Rust Analyzer in terms of linting and hints like that doesn't really work the way that you want. It'll always think that something's wrong, which is a pain. So I'll show you my kind of weird workaround for that. I am going to develop in Linux tonight. I could technically do this in PowerShell. I could use Cargo and PowerShell to do it. I'm not going to do it for a couple of reasons. Reason one is I don't want Microsoft seeing what I'm doing just yet. And part two is I actually much prefer the build pipeline in Linux despite this one weird problem. Okay? And also, Git with file permissions in Windows gets a little annoying, right? If I have a Git repo that I have in Windows and then I move it over to Linux, the file permissions get squiffy, and I don't like that. So, for that reason, we're going to stay here in good old Linux, and it works fine. But let's sort of think about some of our prerequisites here. Things that I know we're going to need. We're going to need build in Linux, compile in Windows, makes me want to cry to sleep. So I've been trying to get comfortable with doing Rust in Windows for situations like this, like exactly situations like this. And it's like, it's fine. It works. And like specifically with Rust, but I much prefer the whole experience in Linux, just like everything. So we're going to stay there and live with this one particular quirk. So, to get started, we know right off the bat that there are a few things that we're going to need. Now, we've got delete snapshots, IVSS backup components, VS backup. So, because of all the things that we know that we'll need, we'll kind of walk this back. The way that Win API works is that you get Win API and then you add features to it. So we'll start by doing cargo add Win API. Which, by the way, if you haven't been playing with Rust that much, this is a new thing that Cargo can do in like the not too recent past. Or sorry, not too distant past, where you can actually add packages or crates directly from the Cargo command line, which I much prefer. Is the compile what's sending bits Microsoft or is Defender? Reckon excluding Builder from Defender will hide it enough. So I don't trust Defender at all. Okay? Because there's different parts with this specifically. There's different parts of this because Defender, like even bog standard Defender, there's the scanning that it does and things that it monitors. But I don't trust that any calls to the Windows API that may emanate that match a heuristic don't get submitted anyway. Yeah, and I can turn off cloud. Well, Freedom Dow, congratulations on having our first off-topic question on the night. I don't know anything about quantum computing. Just to show you, we'll try this. No, this won't work because I don't have my SSH key on the Windows side at all. All right, cool. So now that that's done, so cargo add is kind of interesting. now that we have it. If we look at the instructions for it, you can add, I think, yeah, you can add features as well. So for example, if we go back and add with -F, we can do some of the features that we'll need. So for example, we know that we'll need VS backup. And that's kind of the way this works in the WinAPI crate is, right, the user mode, which is what the UM here is for, and then the VS backup. So this is the feature that we need. So we will add VS backup. We know that we need that. And now you can kind of see it tells us what's enabled and what's not, right, in this export. So we've added VS backup. And look at the other ones. It actually tells us the other ones that are available to us. And you can see there's also VSS and VSS error. I suspect we're going to need those as well. So we're going to do VSS error. What else? I think for now we'll stay there and see what else we'll need. And again, you can see that we've added those additional features. No trouble. And now, one more that I know that I'm going to want, which is litcrypt for encrypting our strings. If you're not familiar with litcrypt, super handy tool. It will, at compile time, encrypt any string primitives that you have in your Rust code, which means that those strings then cannot be used for static signatures or Sigma rules, or Yara rules, I should say. And it's a good habit to get into. One trick is when you use litcrypt in this way, you have to set an environment variable for the encryption key. So we're going to set X, the litcrypt encrypt key is the name of the environment variable. Set it to corroded Charo. I'm not having a stroke. That is how you set or how you export environment variables in Fish, which, by the way, is getting rewritten in Rust. And then we're ready to launch VS Code. Phenomenal. All right, everything looks good. We've got main RS, not a whole lot going on here just yet, but we will begin. So we'll start here, and we'll say, do I need any standard imports right now? No. So we'll just say external imports. I've taken to structuring my my header this way, just so it's nice and clean. So let's see, mod litcrypt. No, use litcrypt. There we go. We don't need to call it, just declare it as a module. And yeah, use litcrypt and LC are the two things that we need from litcrypt. So this use litcrypt is a macro that rewrites a good chunk of the top of your code, basically to make any string statement turn into an encrypted string. It's pretty crazy. It sets up the encryption functions basically for you, so you don't have to write them. And then LC is the macro that you wrap your strings in to turn them into encrypted strings. All right, so that's our externals. And I think that's all we need. We don't have any standard library imports yet. I'm sure we will. But for now, let's make that though. CD imports. By the way, very, very uncomfortably, I was a member of an honor society in college. It was the English Honor Society, which was definitely, it was Sigma Tau Delta. So thanks for that, whoever thought that was a good idea. Oh yeah, right. So we will definitely need a couple of imports from the standard library. We're just not there yet. I didn't realize you can use VS Code Terminal. Yeah, it's actually my favorite way of launching it because it launches it directly in the folder. And by the way, that works on both Linux and or WSL, which is what I'm using here, and it works in PowerShell. So if like, what do I have in projects here? Oh, cool. There's the LCARs. If I go into the LCARs CSS project, which I haven't looked at forever, if I fire up code here, it opens in Windows. Yeah. Okay. So, what are we doing? Oh, right. So to make this happen, our external imports, we'll use WinAPI, and this is where this is going to get a little bit interesting. So far, we need UM, and then what do we need? We need VSS, right? Oh no, VS backup is really where we want to be. VS backup, IVSS backup components. So we're going to kind of, let me hop this over here. And so VS backup. You can see already that this isn't really doing any auto-completion the way it should, right? Now it will, I believe. I just need to... It's all saved. Rust Analyzer. I think we need to get those crates down. Oh, no. Let's back up. Back up. Components. Let's do delete snapshots for now. And, all right, let's see how that goes. Oh, great. Could not find UM and WinAPI. Oh, interesting. So, did I forget to add? Oh. Let's try this. If we don't have hinting on this, we may have to move to Windows as much as I wanted to do it elsewhere, which is fine. All right. Hold up then. Luckily, I updated Rust in both places specifically for this reason. Yeah. Okay. PowerShell. Where are you at? And you. We'll do it over HTTPS. Sea Lion. I've seen a couple of references to that IDE for us. Yeah, you can use JetBrains Sea Lion. I don't. I use VS Code. Kuchi with PowerShell core. The issue is not PowerShell versus other shells. The issue is that the crates literally won't compile on Linux to get us the Rust Analyzer data. Like, it'll compile at the end of the day, but we won't get any useful hinting. So, like, you can do it. Fine, we'll do it hard mode. We'll do it hard mode without extra hinting. What that means is we'll just have to be very, very careful. But the other thing that means is that this is going to yell at us eventually, right? It says, oh, this isn't a thing. Oh. Or is it? Yeah, it says it can't find WinAPI, right? Well, watch what happens. If we do cargo run... oh, crazy. Could not find UM in WinAPI. Right, so cargo run will fail because it's building for Linux, right? If I do cargo build for Windows, though, now it gives me a different error. I did make a mistake, but it was a different mistake, which is IVSS backup component is a struct, not a module. Right? So you see that it's actually giving me proper errors, but it's not going to give me proper errors until I compile for Windows, right? Which is kind of a pain. And honestly, in order to teach this, I would prefer to have those errors come up. So for that reason, I'm going to leave this alone. We're going to try this over here. Okay. Let's look at the difference. Oops. I opened the wrong folder. CD corroded shadow. Nope. There we go. Let's open this here. And let me just turn Defender off. Ooh, I can use the cool version of turning Defender off. I wonder how many people know this trick. I found it because it was undocumented. Let's see, program files, Microsoft. Is it program files x86? Windows Defender. Yep. MP CMD. Come on. Is that all that's there? Hold on. Sorry, this is a cool trick and I want to do it. MP CMD run. Yeah. Should be there. Really? There it is. MP CMD run. It's going to be here. There it is. WD disable. But it failed. Perhaps because you need to be system to do it. It's not... No, Defender's not 64-bit. It has to run everywhere. This... Friends. This ain't my first rodeo. Take a look at the top left corner. I'm running as admin, okay? But no, there's another issue, which is fine. I'm not running it as system right now, and that's okay. Oh, the issue was that it was already off. All right. We're sorted. But this is a legitimate command. WD disable. But if you look in the help for MP CMD run, it's not documented. I found it because I saw Kaspersky doing it during an install. When I was testing third-party antivirus software and looking for WTF bins. Okay, so now we're in Rust still, but we're in Windows land. Right? And let me make sure I have the Rust extension installed on the Windows side of the house. Ah, see? I don't. Oh, no, I do. Okay, we're good. Wunderbar. Okay, so now if I go into main, let's re-add. Let me fix that. CP source, or actually cv cargo.toml. Mount E projects corroded shadow. Cool. And source main.rs. Ah, yeah. So WSL can write to the Windows side easily, but the Windows side can't write to the WSL side, like at all. What you're saying is you can easily make a USB drive with run as administrator, plus that command prompt, plus toolkit, then you own any modern. No, don't. First of all, if you have an admin privilege on a system, let's just clear this out. If you already have an admin privilege on a system, you already can run a system, okay? Like, you can already do that. Let me show you. We'll do this the old school way so you can see it happen. This is the task scheduler. I'm going to create a task, okay? Any task, right? I could run calc if I wanted to, right? Or whatever. But then, check this out. For any task that you make, and this is something you see threat actors do all the time. They do it with the scatasks.exe command line. But once you do that, check this out. Use the following user account. Change user or group. Boom. I can just run it as system. And so if I'm running a reverse shell or a C2 agent or something like that, now I have system immediately through this scheduled task. Now, any endpoint detection and response software worth its salt should catch this happening. But if your concern is privilege escalation, once you have that admin token, you're home free, right? To get to system. Now, the next hard part is, can you access the local security authority subsystem to get at other credentials, things like that? That's a little bit trickier these days. But just getting to elevated privileges? Nah. Windows gives you tools to do that. Right. So here is so what do we want? We want IVSS. There we go. We want IVSS backup components. See how it's auto-completing now? This is why it's good. So IVSS backup components. What else do we want? I think that's it for now, but I know that it's going to grow, which is why I've structured my imports like this. You may not have seen people do this in the past. Hey, 0xD6N, thank you so much for the follow. I know that I butchered that. You may not have seen people structure their Rust imports like this before, but I'm a big fan of it when you have a lot of nested stuff, because we know that we're going to be in user mode, the user mode section module for a long time, but we won't always be in VS backup. So let's say the next thing I need, let's say the next thing I need is from VSS, right? Now I can get whatever I need from VSS, and it's just nice and clean that way. So it's really just a style thing that I've picked up, but I've really found it to be quite handy. Okay, so we know that we have backup components. Now, this is kind of interesting. IVSS backup components is a struct. It's a struct, which means we have to instantiate this thing, whatever this thing is, this IVSS backup components. And this, friends, is where we really start getting into the Windows API programming. Because the IVSS backup components class right here, right, we have to build it. Or we have to work with something that produces it. And this is really where we have to start reading the Windows API to understand how we make this happen. Right? And we're in this VS backup. Look at this create VSS backup components function. Okay. Creates an IVSS backup components interface object and returns a pointer to it, which means we obviously will need to use this function as well. Create VSS backup components. So we know we're going to need that. how does it work? Well, luckily, VSS backup components takes a single parameter. If you're new to Windows API programming, and by the way, I'm not an expert in any way, shape, or form at Windows API programming. I am absolutely just feeling around in the dark here. But I have been very interested in learning how to do it in Rust, which is why I've been doing things like this. So one of the things you have to get used to, if you haven't worked with C or C++ or the Windows API a whole lot, is that some of the parameters to functions in the Windows API will be in parameters and some will be out parameters. Put another way, if you're used to programming generally, you're used to functions returning values, right? Where it's like, if you have a function called add, that function will return the result of the two parameters added together that you give the function, yeah? That's not really how it works in the Windows API. Instead, add would take 3 parameters. It would take the 2 terms that you're trying to add together, and then the third would be essentially a pointer, a location in memory that the result will be stored in. And that's called your out parameter. So here you can see that we have an out parameter, but nothing else, which means it doesn't take anything in, but it does produce what type? H result, which is a handle result. Handles are pointers in the Windows API. Okay? That's the basic idea. Now, it's a little bit tricky, though, because the type that we're sending in is this double pointered thing. Handles, not handlers. Notice this double asterisk here. And by the way, we're reading the C++ code. Let's look over at the Rust code to see how it's different. If we look at the create VSS backup components, you can see it's a little bit different. So let's start working from here. We know that we're going to need backup components. We're going to say print line making or creating backup components. And then, and you know what? We're going to wrap almost all of this in an unsafe. Why? Well, you can see that I'm using an unsafe function here, and this is some Rust inside baseball. What is unsafe? Unsafe does not mean, I think a lot of people when they first see unsafe when they're learning Rust, they think it means, oh ho ho, that means that it's vulnerable to buffer overflows and heap overflows and use after freeze. No, what it means is that the compiler can't guarantee that it isn't. That's an important distinction. It's, put another way, unmanaged code. Right, so unsafe means that the compiler is not going to put, the Rust compiler is not going to put any of its normal Rusty checks on the code, because it can't, right? You're calling external functions that are outside of the Rust language. It can't make those guarantees. It can access that code, but it can't really make those guarantees. So that's what unsafe is about. It's very common, like when I started learning, I was like, oh, okay, this is just like, if somebody got to this code, they could drop a, they could pop a shell with it. No, it just means that the guarantees are elsewhere. How did I learn all this? Practice! Much practice. And deep curiosity. Which is the lifeblood of, I think, a technologist of any stripe. Sorry, it was bothering me that the Chiron wasn't centered. Okay, so we're going to create backup components. So we know that we have let mute, and this is kind of interesting, let mute backup result. Let's call it, backup components equal. This is where we're going to start getting into some real weird stuff. So we know that it is going to be of type IVSS backup components, kind of. But it's not just that. Because we also know that this thing is a pointer that we're giving it. This is where we have to import some stuff from the standard library. So I'm going to use the standard pointer and the standard mem zeroed function. So pointered, and actually, do I just need null mute? I think I just need null mute. So these are really important. We'll talk about what that is. Let's look up null mute here. Creates a mutable raw pointer. A pointer, notice that asterisk. Very similar to what we saw in the Windows API documentation. Now that's one asterisk, not two, which means we're going to have to reference it again. We're going to have to do a reference to a reference. But we're on our way. So the pointer is stored. So think about, why are we storing things with pointers? We got to use that data. I promise there's a reason for doing it. Don't try to second guess the API design right now, okay? Just absorb it rather than trying to contradict it. I know that because you don't understand it, there's always an instinct to be like, but it must be wrong. Let that go. It's designed this way for a reason. In this case, the reason is we will eventually be putting the information in one place in memory. But before that happens, that location, whatever that location has to be, happens to be, is going to be sent to a bunch of different functions. So rather than doing the hard work of moving all of that data, however big it is, all over the place to each of those functions, which, by the way, Rust doesn't let you do anyway, but moving it from place to place, instead of moving all of that data, forget that. Instead, we're going to move a reference to that original location from function to function to function. That reference is always the same size. It's small, and it won't change. So that's why we're doing this with pointers. The mute keyword, by the way, means that we're going to change it. But we know that we want this to be a pointer. So if I say equals null mute, right? We're going to get yelled at by the compiler. I can close this. What does it tell us? It's going to tell us, hey, you told us it was IVSS backup components, which we did, but you just made a null mute. So what we're going to do is we're going to add that second pointer, that second reference, basically, with a mute here to say, oh, this is actually a mutable pointer to one of these things, which doesn't exist yet, but stay tuned. And now we're good. So now we've told the compiler, okay, this is going to be a pointer to a thing that will be of type IVSS backup components. It doesn't exist yet, so chill out. And then it says, oh, okay, you're a null mute pointer. I'll lay off, which is why it stops yelling at us. That's our first step. Okay. Now, we saw here that we're going to need hresult. Where does hresult live? Let's look it up in the Win API documentation. It's Windows docs. We don't need that. Let's duplicate this tab. We're going to make a bunch of tabs. And in fact, I'm going to do a little Vivaldi and stack them. So I've got the Win API stuff all in one stack. Here, we're going to look for hresult. Okay. There it is right there. It's in WinNT. Now, we know that it's of type C long, but we want to name it what it is. WinNT is a new feature that I need to add, right? So I will go ahead and use PowerShell, cargo add WinAPI f WinNT. Kaboom. And now I can add winNT hResult as one of my imports. The pointer is immutable or the target is immutable. Actually, both of these are mutable. The hang-up. Interestingly, in Rust, immutable is the default. So only by adding the mute keyword or particle, if you like, do I make something mutable. So what we're saying here is not only is the object at the end of this reference chain changeable, but also the pointer is changeable. And it has to be because of the nature of this thing. Okay? I know that this is kind of a slow roll to get started. But we'll start here. So we'll call it HR and say that it's an hResult, and we'll initialize it to 0. And let's see if we can create backup components. Actually, we'll just call it equals, yeah, create VSS backup components. And we're sending it backup components. Or are we? Check this out. So it says mismatch types expected a double reference, a double pointered object, right? And it only got 1. To fix that problem, we are going to not send backup components itself, but a mutable reference to it. A mutable reference, I'm using the term reference specifically rather than pointer. There are both pointers and references in Rust. They're not quite the same thing, but here we want a reference. So here I'm going to do mute. And now we can send that successfully to create VSS backup components. Now, it turns out that there are some error messages in the Windows API that are kind of hard-coded, okay? So there's this thing called SOK and SError, and they're both inside of WinError. And they're also inside of shared, which is kind of interesting, right? Not user mode. It's something that both kernel mode and user mode uses. So that's something to be aware of. And for that reason, we actually should have it. Let's see if we can get WinAPI UM. Yeah. So this is where we're going to actually have to add another level of curlies here. Yeah. This is why I do it this way. Shared. And what is it? WinError. Ooh, which I don't have. Let's look at the PowerShell output to see what option I need here, if it shows me. WinError. Yeah, we have to add WinError, which is fine. WinError. Lovely. Now I should have SOK. I do. Wonderful. And there is also, I believe, another one, which is something like, yeah, like e-access denied. So we'll bring those in as well. Need another brace? No, I'm good. I think. That's why I have these colored curlies here. White, pink. Pink, blue. Yeah. Everything looks good here. And the reason I want to do that is we'll say if HR not equal SOK. Just for now. Okay. We run cargo run here. So it ran. Our program ran, but something went wrong. Why did it go wrong? Well, for one thing, I'm not running this as admin. If I go into the same directory with my admin shell, and do cargo run, works just fine. So we're successfully able to create backup components. We're able to get that backup components thing going. So far, so good. Now, if you want to see what it looks like, we can do that. We can do a little else here. By the way, there's a much better way of doing this in Rust, which is rather than doing an if-else, we do a match HR, and then we'll do an SOK, in which case we'll print line Oh, I was like, why? What's wrong here? I forgot the fat arrow for the branch, right? And then we'll do a print line, and we'll do. I think that's right. I think that's right, but we'll confirm it. Confirm it over here. Yes, that's how we do hex. We print line. All right. With that, where's my admin shell? We'll just pop this over here because this is what we'll use for the cargo runs. Ooh. I forgot. I got too eager. I forgot to finish the match statement. Everything else will say line couldn't create backup components. All right. Is there some reason cargo run is not saving to my... There we go. Okay. So it's zeroed out for the moment, which 0 is okay, right? That's actually how that goes. So that's fine. Okay. Then, what else do we need? So what does the backup components allow us to do? If we look at our documentation for these things, what do we have? We have set backup state. We have initialize for restore, get rid of blah, 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 blah. We have our methods down here, which is really what I want. there's this thing called query. And what query does is allow us to query the VSS backup components for the kinds of stuff that it contains. The queried object ID, which is of a certain format, type VSS ID. We'll have to import all these, by the way. VSS object type, and of course the pointer where we're going to save this stuff. It's very similar to what we did with our backup components. So we'll actually do this up top here. Let mute enum object. And we'll import some types here because we know we're going to need this. We're going to need VSS enum. Come on. Oh, you're in VSS. So that's like, oh, it's so annoying. That's in VSS. So we'll need IVSS enum object, right? See how they're in a different module? So we have to be very careful about how all that goes.
Now my life kind of centers around the games, arcades and stuff. Right now that's my thing.
Women's soccer, U.S. women's soccer won 2-1 over Brazil. That's a big win, I think. I don't know anything about soccer or football. But congratulations to them. Same deal. We'll initialize it as a null mute pointer, and then we'll fill that in, which will happen because of the query, right? But while we're here, we know that we're going to need a VSS ID, and we can see by the path, by the way, that that's all in VSS. So we're going to need VSS ID, VSS object type. By the way, I don't know if you saw it, VSS object snapshot and snapshot set, but like, that's what we need. We need VSS object snapshot. That's what we're querying for. And I think that's it for now. Okay. By the way, because we imported this e-access denied, we can create a match branch here that uses it. It says something like run as admin, you doofus. Okay. Which, if we go to our... Hey, there it is. So that confirms we were getting the access denied, right? So that's handy. That's why we use these predefined. They're just integers, but we use the predefined codes so that the error handling is semantic. It's very easy to see what it is we're doing, even though they're just integers. And by the way, if you've ever gotten a weird like Windows error code like this 0x8007005, if you ever got one of those, that's what you're getting. That's what those are. Okay. So we're creating, okay, we need the enum object. Create VSS backup component. Yeah. No Windows RS? No, Eminence. This particular set of API endpoints is not in the first party crate. We have to use WinAPI for this. I would much prefer to use the Windows RS crate because I can run it on Linux, but can't in this particular case. Oh, you know what? We want to do... I did make a mistake here, which is let mute hr each result equals 0, and then we do that. So this is, again, it's a pattern I need to get out of. When we're working with Windows, the out variable, wherever we're sending stuff, is different than what is getting returned. So this returns the result, success or failure, right? But I actually need, this is the out parameter. This is where the backup components are going to get stored. So now, having done that, I should not be overwriting the pointer. It should look real in this case. So let's give that a go. Still no. Oh no, match HR. Yes, but I'm printing the wrong thing. I want to print backup components. There we go. The trait bound. Oh, hilarious. As ref. Thank you. Come on. Oh, dot unwrap, maybe? Yeah. What do you want from me? But it's just fine. Whatever. We won't worry about it. All right, so that's all good. Try and mute backup components as mute. The issue wasn't the referencing, Eminence. The issue was that the struct didn't implement representation as hex. Yes, but the pointer should be able to... that's true. All right, we'll give it a shot. No. Minus mute underscore. No. 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 I'm not worrying about this right now. We have other stuff to worry about. Okay. So, after creating the backup components, we need to be able to query the thing. What does querying the thing look like? Well, we're querying. So now that we've created this... Oh, actually, hold on. Yeah, there we go. I could have also just returned, but... Now... Is the return value create VSS backup components being saved in HR? It absolutely is. Great point. Oh, HR equals. Now it is. You're backseat driving? Well, join the club, Eminence. That's really what everyone's here to do. It's one of those, like, beach bike things that have 7 steering wheels on it, and everybody has a pair of pedals. But we have query here, so the way that this works is we need to give it a VSS ID, but this, I believe, can be, it's a GUID, but it can be null. And then the queried object type, which in our case is going to be snapshots. Okay, but in order for that query to be null, we need to have a type of null, which gets a little bit interesting. So if we just look for GUID here, it's quite a bit. If we look for GUID null, we'll see that there is something called GUID null in CGUID. Now, we will add CGUID as a feature to WinAPI and add that as something in our it's in UM. My bad. CGUID. There we go. GUID null. Very good. So that's kind of the first thing that we're going to need to query. To make it a little bit clearer what we're doing here, let's start writing the function. Backup components.query, and see how it has all this stuff. So the first thing is the queried object ID. And as we saw, was that not here? Yeah. In query, the first one is the VSS ID. So this is why we have GUID null. So the first one we'll do is the GUID null here. Then the queried object type. Oh, thank you. Thank you, Eminence. That's really helpful. Makes a lot of sense. I don't do a whole lot of programming down at this level, which is why I'm not that familiar with that debug display. But I would like to show it, so thank you. All right, so now we need to do queried object type. That queried object type is going to get pulled from someplace else. We have the snapshot type. And the returned objects type. So the queried object type, I believe, actually is none, which we have to get. Object none. Yeah, because we're not querying an object, really. We're querying the backup components. There's no sub thing that we're doing. So this is going to be SS object none, but then the returned objects type. This is going to be interesting. So we actually are going to need... Hold on. As I'm saying this sounds wrong. Let me check. My notes. Yeah. Oh, yes. Great, yeah. Self. Object type. None. Returned objects will be snapshot. And then where we store the thing. Okay. So I don't know why it's giving me like... Is it just the hints that are messing me up? Maybe it is. Because we should do snapshot, and then the next thing we need to do, yeah, there we go, is the thing that we're gonna end on, which is the enum object, right? Which we've already created. That's our out for that. And that's a little long, so we will format this slightly differently. And of course, just like we did before, we're going to have to do another reference for that. And this, I knew this was coming. This error here, where it's going to say something insane. No method named query found for raw pointer. Even though it was more than happy to give us this autocompletion, it's actually the wrong type. The reason why is because this thing's been a pointer the whole time, right? But the query method isn't on the pointer, it's on the thing. So indeed, we have to use asRef. And asRef returns an option, I believe. So we have to unwrap it. And that will give us access to the actual query method, right? There we go. And again, we're going to say that that is, in fact, going to get the result code is going to get stored in the handle result variable that we already used once. But because we're just using that to store the result sequentially, we can use it again. And kind of do the same thing, where we do another match HR here. And this time, we will say success, snapshots queried. I don't have a particular need at this point to show us the pointer location. I kind of want to do that the first time just to kind of demonstrate it. Again, we'll run, I don't know why this would happen. So we'll knock this off. Anything else? You know, if we can actually learn here a little bit about how this works from the Windows API. If we look for the query method here, queries providers on the system and or the completed shadow copies in the system that reside in the current context. The method can only be called during backup operations. This may require us to do something a little bit interesting, but we'll get there. So we have different return values. There's SOK. Now you can see these codes. Invalid arguments. Unexpected error. We'll add an invalid arg. I think that might actually be helpful for us. So we'll import that as one of our things. Yeah. Yeah, okay. So what comes back then is this IVSS enum object, which itself isn't an iterator the way that you're used to iterators. Okay, so it's not like a loop thing. We can't do for shadow copy in IVSS enum object or whatever, right? We can't do that. It does, however, have a next method. And that is what we'll be accessing. We'll take a look at the Windows API information. You know what? Let's stack these two because we can. I'm obsessed with these stacks. Hey, Blacksmith Prime. Quick questions, then I got to rinse since I'm stuck at work. Okay, happy I was here for you then to answer this question. I see you have an EWP cert. Do you think the EWPT is a good cert after the PWST? I'm looking at certs that'll help me secure a new position. What Blacksmith Prime is referring to has nothing to do with what we're doing here, but it is a course that I wrote. The Practical Web App Security and Testing is my course at TCM Security Academy. It's about practical web app security and testing, as the course title might suggest. Blacksmith Prime, I wrote PWST with the eLearn Security Certified Web App Penetration Tester exam in mind. So it's not like official courseware, but I wrote it with that exam specifically in mind. After taking PWST, in my opinion, you are well equipped to take that test and pass it. If you've practiced and feel comfortable with all the skills that we discuss in the course. Hey, Sar. Good to see you. Sar Sek, the Taggart Institute's resident professor of Pwn. I love this track. It's so atmospheric. And you gotta love a band called Laserhawk. So, yeah, next is what we want. Now, the way that next works is a little bit tricky. You can see that it has in the number of elements to be read from the list of enumerated objects into the ergelt. I don't know why they're called this. Buffer. And then the address of a caller allocated buffer that receives the object prop. And how many things have been fetched, basically. So we have to set up the storage for these things. So it's going to go a little bit something like this. We're going to print line, fetching shadows. And then we'll set up just the counter, right? Which is going to be the, this out variable here. So let mute fetched. And it's a ulong, which in our case would be a 32-bit. So that's u32 equals 0. Which you can also see here. Okay, actually it's going to be this one. And then this is where it gets a little bit crazy. We can't do a for loop. We have to pretty specifically just loop until we can't. Hey, TJC Hacking, thank you so much for the raid. Hope your stream went well. Yeah, we're going to do this thing that they tell you in computer programmer school never to do, which is a nominally infinite loop. Which Rust just has. It just has a loop structure. So we're going to use it. And inside this loop, quite a bit is going to happen, because this is for every volume shadow copy. Okay? So again, we're going to use that HR. We're going to call, because we're calling this next. Okay? And we need one more variable. We need this VSS object prop thing, which we haven't imported just yet. Object prop, let's get that. Now the VSS object prop is similar to what we saw before, but it's a little bit different. For this one, a null mute pointer isn't quite what we need if we look at it. Because it has a little bit more structure going on here. So we're going to do, this is why we imported zeroed. To make this happen, I'm putting all these up here at the top here. So we're going to do let mute prop, VSS object prop equal zeroed. What does zeroed do? Let's go look it up. Returns the value of type T, represented by an all 0 byte pattern. So it's kind of a way of getting around some of the type checking when you're dealing with foreign function interface like we are here, where yes, it's going to return, it's going to read to the compiler like that's that type, but until you actually fill it in with the correct bytes, it just is a reserved space in memory made of zeros. That's the basic idea, and we're going to use that for the VSS object prop. Now, we're going to fill this in with each result of next. Okay? Because remember, that was one of our output variables, if we look at the Windows API version of that, right? That's one of our outs, and then how many things we fetched is in the out as well. And then in is going to be one, right? Yeah, just one every time. So we'll do query, or sorry, next, my bad. So now that we have this, we'll do enum object, and we have to do this nonsense again, this asref.unwrap, to actually get access to it. Asref.unwrap.next, there it is. Awesome. And again, just to make this a little bit cleaner, I will drop these down like so. Okay, so Celt is how many things we're querying. That's one. One at a time, please. And then we've created this prop up here, which we're going to send in as a mutable reference. And then the fetched we already have here, which also we're sending in as a mutable reference. Okay. Yeah. Okay. And by the way, that fetched is how we know to stop. If fetched equals 0, meaning there's nothing else to fetch, we can and then we'll just exit 0. No problem there. But while we do have shadow copies, we're gonna go get them. So this VSS snapshot prop, hold on, object prop. Right. The object prop. .obj gives us an object union. So all the way down into this, right? The prop has this obj field that has a snap mute, which is what we want. This is where all the snapshot information actually lives. So finally, we're getting snapshot info. It's taken this long to get there. I'm going to say let snap and mute VSS. Oh, I need to import that, don't I? VSS snapshot prop. Yeah, there we go. VSS snapshot prop equal prop, which, if you remember, was one of our out variables here. VSS object prop dot obj, there it is, dot snap mute. That gives us access to the snapshot data. Now, the snapshot itself is pretty weird. If we look at it, it has this snapshot ID thing, but the snapshot ID, this VSS ID, has GUID components, right? And so if we want to display it, it's a little bit tricky. And this is the easiest way I've seen, just so we have an easy way to do it. So we'll print line. We'll do this 4 times because there's 4 parts of the GUID, right? Yeah. Sort of. This isn't a perfect representation, but it'll do the job for us here. So what we'll do is that snap.m snapshot ID data 1. And you know what? This is long enough. We'll do this on multiple lines. I'm a stickler for line length. I prefer vertical to horizontal. And by the way, so do your eyes. I don't know if anybody ever noticed this, but as a human, which I definitely am, your eyes are better at looking down and up than they are looking left and right. And you can notice this if you're really aware of what's going on. If you move your eyes all the way to the left, all the way to the right, all the way to the left, all the way to the right, and then compare how that feels to moving down and up, you will notice that it feels much, much harder to move all the way to the left, all the way to the right. Your eyes, which are lazy, like the rest of your corporeal husk, prefer to move up and down. For that reason, that's one of the reasons widescreen monitors are a little bit funky for text, because you actually don't want a wide column of text to read. You much prefer a vertical. And what that actually means in terms of reading comprehension and retention is if a column of text is too wide, like if it goes too far left and right, your eyes will just say, screw it, I won't bother with whatever's over on the right hand or left hand side, depending on where you're starting. And you miss stuff. It's like a physiological reality of how we interpret information, which is why, again, when we're on wide screens, you want to narrow your text columns so you're not missing stuff. Okay, snap.m snapshot ID data 2. We'll just copy pasta the rest of this. Data 3. I think they say 10 words wide. Well, in what font size? And how big are the words? That's the other thing. I mean, you can't really generalize like that because of the way that words are. We once you learn to read, you also, the letters make the words, but the words themselves become recognizable images for you, ideograms, and so they're not, or logograms really, and they're not it's a little bit harder to do something that quantitative. And plus, it's language specific. Like 10 German words wide? That's a pretty wide column, depending, right? Okay. Now, we do have an HR here, so we're going to do another one of these match HRs. And we're going to use that. Yeah. And I'm going to put this if fetched inside the SOK. And everything else, actually. Because there is a very real possibility that something has gone wrong here, and I want to account for it. Yeah. Is that right? Yeah. Yeah. Okay, let's see how that goes. Couldn't create backup components. Interesting. And I'm in admin. Oh, because it wasn't actually that. It was snapshots queried. Couldn't query snapshots. Is really what it was. And I expected this to happen. Yeah, see? Couldn't query snapshots. I expected this to happen, and here's why. If we look at the query information here, it says this method can be called only during backup operations, which we didn't set up. In fact, there is an initialize for backup method. Initializes the backup component's metadata in preparation for backup. And this is where things get really interesting. So we have to backtrack a little bit and add some stuff to our code. We know we have to initialize for backup. Or something. Let's see. Oh no, because it's part of components. So initialize for backup, optional during imports. So let's try that. We'll try. We have to, before we query, we have to initialize for backup. So say HR equals backup components. Very much like this, as ref on rep. Dot initialize for backup. Now, this is optional, but it's not in Rust. So we're going to do this as 0 as 816. Because if we look at it in here, initialize for backup. Yeah. U16, I should say. Okay. So again, we will put a little messaging in here. Line initializing for backup. And we'll do another match HR. This one's easy. Initialized. Backup. And couldn't initialize for backup. Okay. Give that a go. So we couldn't initialize for backup. Fairly. So now we're really getting into the weeds here. Why is this true? So the reason this is true is because there are a couple of other aspects of the volume shadow copy service that we haven't touched on yet. And I am building this backwards on purpose. So we need to initialize it for backup. But in order to initialize it for backup, there is another part of the whole architecture that we need to set up. And to do that, we need to get another set of functions and modules from WinAPI, and from this, it's going to be from the COM base API. If we look for co-initialize and co-initialize security, you can see that here. Well, what is that? If we look this up, co-initialize security. Register security and sets the default security values for the process. This is what we need to do in order to allow access to these services. So there's kind of two parts. There's co-initialize and co-initialize security. Right? Or co-initialize X, really. There's co-initialize X and co-initialize security. So we need both of these, and obviously we're going to need the COM base API. So we'll add that as one of our features. COM base API. Very good. And we'll add that in here. I believe that one was UM. Okay, so we'll add that in here. COM base API. I can't type. There we go. Co-initialize X and co-initialize security. Now, these are functions. We need to understand what they require of us. If we look at co-initialize X and co-initialize security, they're going to have requirements. Okay. In particular, co-initialize security has a lot of stuff that it's asking for. Security descriptor, an auth service, all this good stuff. Okay. And I will tell you straight up that I looked up the way to do this the right way, and I found it in C++, and I translated it straight into Rust. So some of these values, we'll look up what they mean, but It's kind of the deal. So we'll start with what we need for the co-initialize X, which is a value called coinit base multi-threaded, which is what we're going to pass to co-initialize X. Right? So initializes the COM library for use by the calling thread, sets the thread's concurrency model, and creates a new apartment for the thread if one is required. Okay, so there we go. We know that it returns an H result. That's why we're using H. We'll use HR again. And then our coinit, the concurrency model and initialization options for the thread, which is why we're using coinit multi-threaded. Okay, so that actually is one of the first things that we need to do, as it turns out. So even before we create the backup components, we're going to do that. So co-initialize X. And this one is optional. To do this, we're going to give it null mute. Whoa. Yeah, that, please. And then the DW coinit, this we will give it the coinit base multi-thread, which we've imported. Wow. Thanks so much, VS Code. Really super helpful. Good. Okay. All's well there. And then basically SOK or SFalse. So we'll take the short one of these. And SOK. Initialized COM. Luckily that's the same, so we'll just do, whoa, no, not what I want to do. Just those two. Thank you. Okay. Let's try just that much. See if we get that far. Okay, we successfully initialized COM, but we haven't initialized security yet. So we're getting there. We're getting closer. Now let's take a look at what we need to do co-initialize security. It's quite a bit more. The access permissions, the count of entries. We don't need all of these. Some of these will be null. Okay? But there are some that we will need. So let's kind of build the bones here. HR equals security, and HR equals co-initialize security. Wonderful. And we'll just put one of these on every line. One, two, three, four, five. Two, three, four. I can live with that. Okay. So, first up is the security descriptor, which is optional. Access permissions that a server will use to receive calls. Used by COM only when a server calls co-initialize security. Okay. But we don't actually care about receiving anything. So this is going to be null mute. Okay. The auth service, which by the way is of type long. The count of entries, as in the auth service parameter that's used by COM. If the parameter is 0, no authentication service will be registered, and the server cannot receive secure calls. A value of -1 tells COM to choose which authentication services to register, and if this is the case, the auth service parameter must be null, which it is, or no, it will be. So this is going to be -1 for us. We'll tell it to do its thing. That also means the next one is going to be null mute. Okay. Up next is this parameter is reserved to must be null. Love that. Thank you so much, Windows API. Really appreciate it. All right, now we'll do a couple more interesting ones. Hey, Tibbs. Good to see ya. I saw you were streaming earlier today. Hope it went well. Okay, impersonation level. Or no. We're up to auth level. We're up to auth level. Okay, so we're going to use some authentication level constants. Solve web app THM room. Cool, which one? We actually want the max here. We want RPC auth level packet privacy. The marketplace. Oh, interesting. Was it like a mage cart thing? That's what it sounds like. RPC auth and level packet privacy. Yeah, we need this. So it's obviously a 6, which we could just give it, but we want to get the actual, if we want to get the actual constant, it comes from yet another library in shared. Right, which we right now just have win error doing, but we'll soon fix that. This is RPC DCE. Oh yeah. So in RPC DCE, we're going to pull RPC C authn level. There's PKT privacy, which is in fact what we want. And there's an impersonation level in here, which we'll use later. So let's pull it authn level, or no, sorry, imp level. Imp level impersonate. This is how we get access to the system stuff, if that wasn't clear, right? Because I said earlier that all of this stuff is running as system, right? So in order for us to interact with it, obviously we need an admin token, but then in the common object model, which is what COM is, we then also have to get up further, and that's what we're doing here, is we're initializing our security context in this way. I hope I'm doing an okay job of explaining that, and if I'm totally off base, please feel free somebody to call me on it. I am absolutely still learning this as well. Okay. So we have that. So now our authentication level is going to be the RPCC authentication level, as you might imagine, and then comes the impersonation level. Okay. The authentication list, which was next. This is used by COM. Yeah. This list indicates the information each authentication the client can use to call a server. I don't think we need anything here, so this is going to be another null mute situation. This is also going to be, the last one is going to be null, as the documentation says. And then finally, the capabilities, additional capabilities of the client or server, specified by setting one or more EOE authentication capabilities, which we will look up. And the one that I think we want here, I mean, we can look these up, but basically we want dynamic cloaking. So we'll pull these in here. Dynamic cloaking comes from, I think, a different library if we look it up. So let's look up Dynamic cloaking. Yeah. So we're going to need to get obgidl as one of our trait features. Obgidl. Okay. Come back up here. And, oh wait, was that? It's obgidl. And I think that's all we need from it, so I'll just do a single import there. Good. And here we'll do EOAC dynamic cloaking. We have now initialized security. As nuts as that is. And again, we'll do a nice little match here. Or just like we did here, actually. Initialized comm security. Again, I apologize if you can hear the canopy out there flapping around. We have, not to bore you with the weather, but we have some insane stuff happening here in California. We have like a historic winter storm about to happen. Like inches and inches of rain, which we never get. And right now we have wind gusts of up to 30 miles per hour. So pretty nutso stuff. Oh, wow. Raid just came in. Cyber Insecurity, good to see you. Thank you so much for the raid. Hope your stream went well. Sidechuck, my name is not Matt. I don't know how many times I need to say that. My name is Michael. Husky Hacks is Matt, but my name is not. We both have biblical names. I understand that. It's okay. We look really similar, so I understand that. I understand getting us confused. Honestly, it's one of the reasons I just go by Taggart. For those of you who just dropped by, you'll love what we're doing tonight. We are implementing some threat actor techniques, and we're doing it in Rust. So one of the things you'll commonly see right before ransomware is detonated in an environment is volume shadow copies in Windows, the backup service that Windows has for itself. Also known as system restore points, if you're used to that. If you're used to those, one of the first things that ransomware will do is it will delete those volume shadow copies. Now, uncomplicated ransomware will do so by just running VSS admin delete shadows. That's an obvious tell. So what we're doing is we're writing a process to delete volume shadow copies in Rust using the Windows API directly, rather than running that command. Right, so instead of running VSS admin delete shadows, we are doing this directly with the Windows API, and we're doing it via Rust. Yes, using the API directly. And we'll walk through the code so far as we have it. We're pretty much there. We were about to fire this off. So, yeah. Yeah, we're ready to run this to see if this works. You're using a lot of books and Mist. Yeah, no, this is, Atris is writing overtime. Let's do some quick thank yous. Do you still new to the stream, so wondering once you go through an attack, do you also go over how to defend against it? You bet I do. I am a blue teamer, okay? By nature. In my day job, I'm a threat hunter, okay? So I spend all of my time trying to stop the bad guys. Hey, the Guar, thanks so much for that sub. Good to see you, buddy. That's a lot of follows, but I want to say thank you to all of them. So very quickly, let's see how quickly I can do this. DJ BSEC, Jake438899, Stuns and Roses, that's a cool one. D2 Danny, Siriano, Long Gone Brew, I apologize if I get any of these wrong. Natural Steak, Fuming Max, Deluxey Cybernuts, Burn 2021, Robcoat 2008, Rabid Moosery, A King's Roar, Beep Boop Beep 43, Soup Dog Soup. Thank you so much for those follows. Really, really appreciate that. Tag before that. And Boot Loopy. Callie, you don't need to refollow to get a shout out. Do I have a LinkedIn profile? I do. I bet you can find it. All right, so let's just see where we are right now. See if this thing runs. See where we're at. Okay, so we initialized COM, we initialized the COM security, we created the backup components, we initialized for backup, queried for snapshots, and then we failed. Yeah, I have a LinkedIn profile. It's in creator mode because too many people were trying to connect with me, and it's like I can't humanly handle all that. Okay, so we failed on the querying of snapshots at the very end here, which is interesting. Let's actually print out the... You know what? Let's actually print out the... result. Let's run that again. It's just a 1. All right. So something else went wrong. Let's take a look at our documentation here. So the query went wrong. That's interesting. We want to be in VSS backup components and query. Yeah. And actually, we want to look at it here. Let's look at the query. One of the things about doing this in Rust is that you kind of have to have the Windows documentation and the Rust version of it open at the same time, which is why I love Vivaldi, because I can have these different tab stacks and switch between the two of them very easily. So, what are my results? Invalid arg, bad state. It was a 1, which is what? We got initialized for backup. Co-initialized security. Oh, there's possibly 2 other things that we need to do. We're almost there. So there's set context and then set backup state. Defines an overall configuration for a backup state. Yeah, here we go. Okay, so we have to pull in some more stuff. CTX all, very good. We'll need that. And I believe we'll also need VSS VT full. Yes. So 2 other things we need to do to set this up. We need to set the context and set up the backup state. If we read this through, it says the set context method sets the context for subsequent shadow copy related operations. And it's going to be, the context must be one of these. Okay. So it's going to be VSS CTX backup, which is the one that we're going to, or sorry, VSS CTX all, my bad. That's, okay, so you can see here, that's what gains us access to all of the shadow copies. Okay. And then, so that's set context. And then we will do We can close co-initialize security. Yeah, close all that. And then we have to do, so set context and then set backup state, right? And these won't be tricky, but they do have to happen. So after we co-initialize, sorry, actually after we create the backup components, then you know what? Backup components happens. Oh, hold on. That print line is just way in the wrong place now. There we go. Put that there. So we are going to initialize. We initialize the comm security. We initialize comm. We initialize the back. We created the backup components. Once we create the backup components, then we set context, and we'll just kind of use the print lines to call our shot here, and then we'll set the backup state. These are the steps. I'm a Pythonista, but it looks like I need to get Rusty. I love Rust, but it is not a great first language. But it is very powerful. Rust is apparently speed demon. It's fast. It's not fast to learn, though. Sudo has a great question. Which Night Ride FM station do you enjoy the most? Been listening to the Chill Synth for my studies. I'm glad you enjoy it. I like Chill Synth a lot. Basically, here's the deal. If you need to get hyped, the OG, the original recipe Night Ride channel is great. If you need to get even more hyped, go to Dark Synth. If you need totally to just space out, Space Synth is good. I'm changing these channels as I talk about them. Data Wave is fun. Little beep boopy for my taste sometimes. Those higher frequencies can mess with me. But tonight, Night Ride is killing it, so I'll stick there. What is Chill Synth? These are all channels at nightride.fm, which if you look at the bottom left of the screen is the music that we're using for the stream. It's a great internet radio station, and they go to the trouble of making sure that what they play is DMCA safe. And so I don't get my stuff muted most of the time on either Twitch or YouTube, which I really appreciate. Okay, so we're going to set this context, and it's part of the backup components. So we're going to do backup components.asref.unwrap, right? Set backup. Yeah, set context. Exactly like that. So we're going to set the context there. And so set context first, right? Yeah, so set context. And it does return an H result, so we'll do exactly what we're doing here. The context is going to be the VSS CTX all that we imported. And again, we're going to use our little rusty match here. And we're doing this basically just as a safety precaution. We could, YOLO through this if we wanted to, but I want to have these safety checks through each stage just to make sure something hasn't gone wrong. So, context set. And couldn't. Whoa! Couldn't set context. By the way, in case anybody's interested, I am actually giving a talk on March 1st at the Anti-Siphon Offensive Summit virtually. It's free to attend. The trainings afterward aren't, but the talks are free. And I'm giving a talk at 3 o'clock Pacific. Nope. 3 o'clock Eastern. On exactly this, on offensive Rust. As a matter of fact, one of the things we're doing tonight is I'm building an example that we're going to be using in the talk for some of the things that you can do. Yeah, I should have a link for that, shouldn't I? Hold, please. There we go. It's like, I know we have it. There we go. In fact, let's even take a look at it together. So here is the anti-siphon most offensive con that ever offensived. So it's going to be a bunch of training from the great folks at Anti-Siphon. I've worked with them before. They're really awesome. I've taken a bunch of these courses. I've done Breaching the Cloud with Bald Bullock. I've done another one that there we go. Advanced Network Threat Hunting. I've done the Chris Brenton threat hunting stuff. By the way, if you've never taken a Chris Brenton course and if you want to become a command line wizard, this is the one to do. It's not cheap, but it's cheaper than a SANS course, and it's way worth it. If you can get your company to pay for anti-siphon training, do it. These are some of the best investments training-wise that you can do. But the first day of the con is completely free, and so I don't know all the other speakers just yet. We don't have the schedule fully finalized, but I am really excited to be one of the last of the day. It ends at 4:30 Eastern. I'll be doing 3 Eastern, talking about the name of the talk is The Subtle Crab, and talking about using Rust to build offensive tools. If you're new to the stream, I will also mention, so some of the other stuff that we've done in Rust for red team work is offensive Notion, right? Husky and I put together a complete C2 written in Rust, and what it uses the Notion note-taking app as the communication channel. So you set up the agent, and it will connect to a Notion page, and the Notion page becomes, as the GIF shows you here, becomes the C2 channel. You can enter commands, and it'll execute on the endpoint. Now, we're actually updating it right now to work over different channels besides Notion. So we have one that works. We have one that works on GitHub. I'm trying to get one that works on Tumblr and one that works on OneNote. But the basic idea is it uses trusted sites that cannot be blocked in any reasonable network, and the APIs are HTTPS anyway. So no matter what channel you use, you're able to use that to communicate with your C2. But under the hood is actually just a pretty solid C2. We have all sorts of different commands: get privs, get system. We do shellcode injection, port scanning, run as. We even have upload to S3 and Azure components, raw shell commands if you want to do that. All sorts of cool stuff. So we'll be talking about the ups and downs of building offensive tools in Rust. That's what this talk is about. Not we, I. Husky will be hiking the AT. All right, back to this. So we set the context. This is looking good. Let's just make sure this is okay. Ooh, it didn't like that. Why did it not like that? Oh, I need to cast it as I32. That's goofy. So in set context, yeah, in here it's a long, but as it's imported, it's not. It's a 64-bit, so we're just casting it down. So that should be okay. Let's run that. we're still not quite there. Oh, couldn't set context. Something went wrong. Oh, I'm dumb. Sorry. That has to be below initialize for backup. And then backup state is underneath that. Yeah, so the sequencing of this matters. Okay. Try it one more time. Oh, snap! Look at that! So we actually got all the way down to querying snapshots. We got as far as we wanted. I'm so confused. You're a threat hunter by day, vigilante, white hat, hacker by night, hacking away to better defend. So, let me explain. Before I was anything, before I was a teacher even, well, sort of, but before I did this, I was a teacher. I was a computer science and teacher. But then before that, I was an English teacher. Before that, I was a martial arts teacher, and I'm still a martial artist. Okay? And I don't believe that you can learn how to protect without learning how to attack. I do not believe that they are separate disciplines. I think that the red team and blue team idea is pretty goofy. Specializations, sure, but the idea that you can successfully defend without deeply understanding what the attack even feels like. Not just, you know, what the indicators of compromise are. No, forget that. You have to understand how the attacker thinks, and the only way to do that is to perform the attacks. There's no other way to do it. And so, I am not, also as a threat hunter, this is the thing about threat hunting that isn't always made clear. Because threat hunting is kind of a buzzword. Threat hunting is what happens when your security program is mature enough to catch the Mickey Mouse stuff. It's what happens when most of the bog standard malware is going to get caught by your automated tools, and your threat hunting is moving ahead of that. Threat hunting moves ahead of automated detection. You're building hypotheses for what would it look like if an attacker was doing this in my environment. In order to figure out the this, you gotta have some attack creativity in you. You have to be able to invent those hypotheses. They don't just come to you from a service. You have to create them, right? So in order to do that, I find that thinking as an attacker really is the only way. And thinking about what else could an attacker do that we haven't seen yet. So that's what this is about, right? We know that volume shadow copies are getting blown away prior to ransomware being detonated. But what does it look like when they know better than to use VSS admin delete shadows? What does it look like when they know better than to drop down to PowerShell to do stuff? Or what does it look like when they know better than even to invoke WMI? This is what it looks like. And so we build it, we attack with it, we learn how to detect it. That's how I threat hunt. But we do so responsibly. So once this is all done, right, we have to make sure that this is responsible. You don't want to deploy anything that could actually be destructive in any meaningful sense. So I will tell you that this kind of code like it, lives in some ransomware that only exists in my work lab. It will never leave. Okay? And the reason is, one, I don't want you to see the whole weaponized chain. That's not responsible. I can't just give that out. Deleting volume shadow copies, like, they're recoverable. You're just deleting backups that are on a single endpoint. That's fine. But I'm not going to show you how to encrypt stuff with Rust. I don't feel comfortable giving out that information. Or certainly providing it as an open source repository. That would be insane. What's the schedule for the stream? All else being equal, it is Wednesdays at 1700 Pacific, 0100 UTC. and Saturdays at 10 Pacific, 1800 UTC. And if you haven't checked out our institute, please do. We have a lot of cool courses that are all free or pay what you wish. We have courses on Vim. We have courses on regular expressions, the Linux command line. We have courses on responsible red teaming, courtesy of Husky Hacks. And we also have courses on learning Python. And Sar, since he's there, we also have a course, a really cool course on the oral history of binary exploitation, which will walk you through the history of how to do simple binary exploitation like buffer overflows with no defenses, all the way through how to do it with modern defenses in place. Okay. So we got the snapshots. We didn't even need to... Couldn't get the next snapshot, but that's fine. Oh, no. We don't want... Oh, so that's interesting. So if we say... oh, interesting. Couldn't get next snapshot. So... Wild. I wonder if that's because of the context. So one thing we haven't done is set the backup state yet. That's like the last piece that we haven't done. So we will do that. Let's set the backup state. HR equals backup components as ref. Dot set backup state. And this one's long. Would I be supporting you directly if I purchased anything from the Institute? No, that's a really good question. So the way that the breakdown works, and we do reports on this from time to time in our Discord, the way that this works is that the course creators who are not me get 80% of the proceeds of any purchases. The Institute, which is, by the way, a partnership between myself and Husky Hacks, it's a 50-50 LLC. We do 20 for just platform support, basically, to keep the site up. That's kind of how that goes. So, for example, SAR will get 80% of any of the material if you buy the History of Binary Exploitation. But it is a direct support of the Institute. Absolutely. And it's much appreciated. We want to make sure that this training is affordable to everybody on Earth, which is why it's pay what you wish. We believe strongly that this information should be accessible to everyone in the world. And we know that even training like TCM, right? I have a TCM course, but I also know that $30 can be too high a price for a lot of folks. That's understandable. So we want to make sure that that material is accessible in different forms. All right, let's set up this backup state here. So we got select components. What are we doing? It's a bool. And so if we do set backup state, indicates whether a backup or restore operation will be in component mode. Support selectively backup designated. I think yes, right? True. True. And then the backup type. We already pulled that in. That's the VSSBT full. And the partial file support, we will say no. Okay. Now what should happen is we get... Now this might just be a logic problem, but since we're saying if no more shadow copies are fetched, we should just exit this way. We shouldn't hit an error. And yet we are. So that's interesting. So that's okay. You know what? I'm knocking off 3. It's unhelpful. There we go. All right. Well, now that we have the error code, we can just say that. Or not. All right. How about now? There we go. Everything's looking good. So how many shadow copies did we get? We got 1, 2, and how many do we have? Looks like 2. Sir Juicy Lemon. Oh, thank you. Thank you so much. Yeah, I do understand that even $30 can be a financial burden. Do you record the stream? You bet I do. All the streams are going to be available on Twitch right away, and they'll be available on YouTube in 24 hours with chapter headings. Okay. We now have the shadow copies accessible. Now, let's do some damage. So, the way this works is that, believe it or not, it's not the snapshot itself that has a delete, it's in the backup components. And this is actually where we began our journey, all the way at the beginning of the stream, was the delete snapshots method. Right? But now we have the ability to do this. We go back to here, we have delete snapshots. Okay? Now we know that we can do this. So again, we're going to do backup components .asref.unwrap. Delete snapshots. Here we go. Now, before we get here, we're going to define a couple of things because this has out. This has out variables. And for those of you who just got here, one of the things that you have to get used to when you're doing Windows API programming is that the functions themselves, yes, they return a variable, or they return a value, which is a result, right? Success or failure or whatever. But they also will often have parameters that will store data, that the side effects of essentially of the function. And for that reason, we have these notations here of in, or out for the parameters as listed here in the documentation. The Rust documentation does not show us that, but you can kind of infer. You can infer which ones are out based on which ones are mutable pointers. All the stuff coming in isn't that. All the stuff going out is that. It basically is how that goes. All right, so let's break this down. Source object ID, delete, PL delete snapshots. Yeah, we'll clear all this up. And Okay. Of course, HR equals. But we'll deal with that in a moment. And we have to make some stuff. So we have to make our two out variables. Say let mute snapshots, or say deleted snapshots equals 0, because it's a long, which is fine. And then we'll say let mute non-deleted snapshot ID equals GUID null, because it's a VSS ID, but that's a GUID, as we've seen earlier. Okay. So this is the current snapshot, this snap variable here. So our source object ID is the snap.mSnapshotID. All right, there's that GUID. The source object type is the VSS object snapshot, which we've already imported. Force delete is a bool, but actually it's not a Rust bool. It's a C bool, which is a 0 or 1. So in our case, it's going to be 1. And then our deleted snapshots is going to be a mutable pointer to the deleted snapshots right there. And here we'll do a mutable, not a mutable pointer, a mutable reference to the non-deleted snapshot ID. And that we'll do a match HR once more and say SOK, print line every time. There we go, print line. By the way, if you have questions about the Rust syntax that you're seeing, please don't hesitate to ask. I am here to teach. I'm an educator by inclination, possibly genetics. My mom was a teacher. I couldn't get out of it. Okay. This thing is armed. When I run this, my volume shadow copies will go. Now, that's fine. I don't care, because I can just make other ones. But this is going to happen. Ready? Let's go. Goodbye, shadow copies. And that is how we do that. We've got a few linting things that we might be able to clean up here. Let's see. Do we seriously not use VSS object type anywhere? All right, we'll knock that off. What else? Do we not use VSS ID? I think that's not true. Yeah, that's what I thought. Hold on. I think it's lying. We definitely use those. Or maybe not. I don't know. Hold on, let me make a new shadow copy. And we'll run it again. Take these out. Yeah, that still works. Okay. All good. What else do I have? So I'm just doing some lint here. Oh, yeah, I forgot to do lit crypt. We'll do that in just a second. So what else do we have? Value assigned to HR is never read. Okay, we can clean that up by declaring it here. And not doing this. There we go. And lastly, do we have an unconsumed? Oh, yeah. Go back up state. Excellent. Okay, now a good question. As you can see, we've got all this linting stuff taken care of, right? We're trying to clean up the code as much as possible, get rid of compiler warnings, all that sort of stuff. So now, sort of the last thing is we imported this use lit crypt, and I want to show this to you because it's pretty crazy. All right, so right now I'm gonna do this thing. I'm gonna do a in PowerShell. Oh, I don't have to do this in my admin PowerShell, so I won't. I can run cargo build release. Hold, please. I think I need to add some stuff to my cargo.toml before we do that, which I'm going to pull right from Offensive Notion, actually. One of the things I've found that's cool about Offensive Notion, even more these days than using it as a actual C2, is that it's basically a reference document for a bunch of stuff that I need to do in Rust. Like, we did so much work on this, I can just go right here and say, oh, okay, I need this. What we're doing is we're doing an optimization for the compile, and we're stripping debug symbols for the release build. That's what that is. Okay? So we'll go ahead and cargo build release. Okay. Now, if we look at our target, you'll see that there's a release directory, and inside of that is a corroded shadow.exe. It's giant. It's like 17 megs because Rust is Rust. But here's something kind of interesting. Okay. Do I have PE Studio? I do. Oh, very cool. Okay. We're gonna look at this in PE Studio. Projects, corroded shadow, target, release, corroded shadow.exe. Okay. So we're getting yelled at for a few things. Here are the strings. These are Rust strings. Those are not particularly interesting. They're understandable. Are any of my strings in here? Yes. Check out all these strings here. So these are things that I have introduced to the binary, right, of my own volition. And I don't know if you've ever taken a look at Yara rules, but some of them are pretty lazy. They are going to use really simple strings, string patterns that are in a specific sample as their signature. But this town deserves a better class of red team operators, so we're going to clean this up a little bit. And we're going to do it with lit crypt. With lit crypt, basically, we're going to take every print line that we have here, and we're going to replace it with print line LC. Actually, hold on. We'll use the power of regular expressions. And we'll capture that, and we'll capture that in a capture group. And then, actually, we'll do quotes. Star. Perfect. Okay, we're going to replace that. Print line LC. Capture this as well. Okay. See. 1. Or actually, that's 2, isn't it? Let me see how that looks. Almost there. One. There it is. Now, it's yelling at me because I don't have a lit crypt encrypt key, which we will fix by closing this. So what litcrypt does I have to call it, by the way. Okay, now what's your problem? Was it like this? Is this what it wants? That's what it wants. Okay. So, we will fix that. So basically what we're going to do is we're going to find LC. And we're going to replace it with think you already mentioned this was your home lab. This is really just this rig. The lab is off tonight. Didn't need to do anything crazy. Okay, so we've now added litcrypt into our code. What this does is it encrypts all of these strings. Now, some of these won't work, right? We now no longer have the ability to do kind of inline formatting with these, which is fine. Right, I'm not too worried about that. There are ways to do that. In fact, we do that in Offensive Notion, but just for now, for clarity, we'll just keep it simple. Okay, so we're this, because what litcrypt does is it turns it into a proper string, which is a different thing in Rust. Okay. Now, by the way, let's just make sure this thing still runs. Let me create a new shadow copy and then blow it away. Oh my. Oh, right, because I forgot to set the litcrypt encrypt key here. Yeah, let's do that, please. There we go. Now it works. Oh, that's nice and clean. Okay, but here's the trick. Okay, now we're gonna rebuild this thing. Okay? Cannot link. Oh, because it's, sorry, that was stupid. Gotta close it. Let's try that again. Great. Okay, now we're gonna reopen PE Studio. And we're gonna look for those strings. Obviously, the string doofus is a good one to look for. These, by the way, are the ones, these are our strings. These are the ones that we wrote. And now they're totally encrypted and unusable as a signature. And as long as you change up the encryption key every time you do a new build, these will be different. And that's it. What about the advice from responsible red teaming? Gotta have something in there. Yeah. Wink. This, by itself, yes, we have to build a signature. But that is different than... So, let me put it this way. You have to build a signature for this, but doing it based on strings is dumb. And that's because if you build, let me put it this way, if you build a signature like a Yara rule based on strings alone, okay? And then you're really not doing much more than a hash, are you? You're doing something that is as changeable. What's the difference? So to make a Yara rule for this, we actually have to do a little bit more work. We have to understand what it is we've built and how it looks. So I think a better way to do that might be to use a tool like Cutter. This is a slightly older version of Cutter, but it should still be fine. Okay. And by the way, if you've never looked at a Rust binary as a disassembly, Oh boy. It's a party. Especially a Rust binary for Windows, because it's going through all the DLL stuff that you need to do, right? The Windows CRT runtime, before we even get to actual stuff, right? And then it's a whole thing. But if we look at the symbols that we have, co-initialize X, co-initialize security, let's see. What else do we have? What? There we go. Create VSS backup components. That's interesting. This is the only place it has. So VSS API, importing this, and create VSS backup components. Those are some tells. There is no delete. That's so fascinating. Let's show where this is cross-referenced. Whoa, crazy. We can't even find the cross-references for this. So that's cool. So I'm going to call it there, and let me tell you, I'm not going to push this out. Search for the system unlink call. I don't know what that means, Grey Hatter. I write a whole lot more code than I disassemble. No, there it is. I don't know why I wasn't... Oh, no, Grey Hatter, this isn't a delete the way that you're thinking of a file delete. This is a different kind of a thing. No. Oh, Side Chuck, that's very sweet of you. I appreciate those gift subs. You don't need to worry too much about the name. God grant me the confidence of somebody who jumps into the middle of a stream to make recommendations without knowing what's going on. And I'm just riffing on you, Grey Hatter. It's all good. But the number of times I will have people just like pop in and be like, I have no idea what's going on. Therefore, here's what I think we should do. That's Twitch chat. I don't know. I think it's kind of just dudes. You know what I mean? Lol, random shots in the dark are low probably, but low risk, high reward. Is that also your dating strategy? It's just a numbers game, brah. Well. Yeah, this is it right here. That's amazing. So all of us, what are we in even? Okay, we're in 14001 DG60. Yeah, okay. What's your whole deal? So things we know that it has to have are co-initialize X and co-initialize security. So those are kind of two things to start with. Yeah, we'll add a new file. Yeah. God, hold on a second. Again, back to offensive notion as my there we go. Perfect. Okay, so we'll call this Road to Shadow. Shadow description. Is it corroded? Hold on. Is it corroded shadow or corroded shadows? Yeah, corroded shadow. Okay. Not Yargen. Okay. It is. Wow, this is almost a year ago? Do we need to have a offensive notion anniversary? That's crazy. Yeah, I can't believe that's true. Okay, we'll do co-initialize X, ASCII, co-initialize X, and co-initialize security, ASCII. And next, we will do a little hex action here. Pretty simple here. Back to cutter. So I think the trick is we need to find where we're... What else do we have? Truly incredible that we can't... Let's see. So stuff that we can't delete, right? Or can't change. Co-initialize security. Create VSS backups component internal. Right? Which we know we want as well. Yeah, create. Copy string create VSS backups components internal. We'll put that in there as well. But that's not good enough. Because we want at least something that is like... Strings. We have VS. That's all we have. VSS API.dll. Nothing in delete. Backup. Shadow. Nope. None of those are there. So we have to be, yeah, very, very careful. Co-initialize security, create backup components. Then we're in this. So F mode. If we think about what we're doing in our code here, we'll side by side this. Look what we're doing in our code here. So beat it. There should be somewhere in here a big old loop. Right? All right, I think we've lost the plot here a bit. Let's go back to entry 0. Let's take a look at our call graph here. Right, initialize zero on time. You. Okay. Then what? Here we go. Now we're getting into it. I didn't expect to be doing reverse engineering of my own dang code tonight, but it is what it is. I guess we could fire this up in a debugger, but for now, we'll do it based on file size here. 170 KB. It's actually pretty tiny. All right. We have ourselves a Yara rule. It's not the best Yara rule in the universe. As I said, it's hard to do these, but we have one. And with that, let me go over to Linux here. We're going to do the mount e projects roted shadow cargo.toml here, and C source main.rs source rs, and what else do I need to copy? Cool. And that, my dear friends, is a working POC for deleting volume shadow copies. All right. Well, that's going to do it for tonight. I hope you had fun. I know that I did. I also learned some stuff. I hope you did as well. Can I suggest a raid target? You sure can, Sar. If you don't know about the hack list, of course, go check out the rest of our InfoSec streamers. But please certainly do suggest a raid target, sorry. Love to have somebody else do recommendations rather than me scouring the list. Kai Pewter? Yeah, absolutely. That was going to be who I did anyway, so that's perfect. All right, so we're going to raid Kai Pewter. I'll be back on Saturday, 10 a.m. Pacific. Thank you so much for all the follows. If I didn't say your name, I really apologize, but thank you so much. I really appreciate it. And yeah, we'll be back on Saturday. Until then, friends, please be good to yourselves, be good to each other, and happy hacking. We'll see you next time.